In the present lecture, we will discuss the GATE previous questions on simple stresses and strains topic. Let's see the first question. Which one of the following is the definition of ultimate tensile strength obtained from a stress strain test on a material specimen? Option A, stress value where the stress strain transitions from elastic to plastic behavior. Option B, maximum load attained divided by the original cross section area. Option C, maximum load attained divided by the corresponding instantaneous cross section area. Option D, stress where the specimen fracture. We know that ultimate tensile strength is defined as the maximum load attained divided by the original cross section area. So option B is the correct answer. Next question. A steel bar is held by two fixed supports as shown in figure and is subjected to an increase of temperature delta T equal to 100 degrees centigrade. The coefficient of thermal expansion and Young's modulus of elasticity of steel are 11 into 10 to the power minus 6 and 200 GPa respectively. The magnitude of thermal stress included in the bar. So let's see the solution. Here it is given the change in temperature. So generally we are using notation is T. Here it is given the delta T equal to the 100 degrees centigrade. And coefficient of thermal expansion is, that is alpha equal to 11 into 10 to the power of minus 6, and modulus of elasticity, it is given the E value 200 GPa. Then you have to convert into the MPa. It is the 200 into 10 to the power 3 MPa. So then you have to determine the thermal stresses due to the temperature change. So we know the equation sigma T equal to E alpha delta T. Then substitute all the values in this equation. We will get the sigma T equal to 220 MPa. Next question. In the engineering stress strain curve for mild steel, the ultimate tensile strength refers to. So it is the stress strain diagram for a mild steel material. So here is the ultimate tensile strength is the maximum stress that a material can withstand without fracture. So here option C is the correct answer. Next one. The Poisson ratio for a perfectly incompressible linear elastic material is option A 1, option B 0.5, option C 0, option D infinity. So we know that for a perfectly incompressible linear elastic material, the Poisson ratio is 0.5. This means when the material is stretched or compressed, its volume does not change. A Poisson ratio of 0.5 implies that the lateral strain is exactly half of the longitudinal strain but in the opposite direction. So this ensures that the constant volume during the deformation. So option B is the correct answer. Let's see the next question. A rod is subjected to an uniaxial load within linear elastic limit when the change in the stress is 200 MPa and change in the strain is 0.001. If the Poisson ratio of the rod is 0.3, then modulus of rigidity is dash. So let's see the solution. So first I have to write down the given data. Here it is given the change in the stress. Let's consider that is the delta sigma equal to the 200 MPa. And change in the strain, let's consider delta epsilon equal to the 0.001. And given the Poisson ratio of the rod, that is mu r 1 by m equal to the 0.3. Then we have to determine the modulus of rigidity, that is capital G. So we know that modulus of elasticity is defined as the slope of its stress strain curve in the elastic deformation region. So here modulus of elasticity E is defined as the ratio of change in stress divided by the change in strain. So modulus of elasticity capital E equal to the delta sigma divided by the delta epsilon, that is 200 divided by 0.001, which is equal to the 200 GPa. So next we have to determine the modulus of rigidity. We know the relationship between the E and G. So E equal to the 2G into 1 plus 1 by M. So we know the E value as well as we know the 1 by M value. Then substitute all these values, then equation will become the 200 equal to 2G into 1 plus 0.3. So from this equation, G equal to 200 divided by 2.6, which is equal to the 76.7 GPa. Let's see the next question. If the Poisson ratio of an elastic material is 0.4, the ratio of modulus of rigidity to Young's modulus is. So here it is given the Poisson ratio, that is mu r 1 by m equal to the 0.4. Then we have to determine the modulus of rigidity to Young's modulus, that is G by E. We know the relationship between the E and G, that is E equal to the 2G into 1 plus 1 by m. Then E by G equal to the 2 into 1 plus 1 by m. Then G by E equal to the 1 divided by 2 into 1 plus 1 by m. Then G by E equal to the, substitute 1 by m value is the 0.4. Then G by E equal to 1 divided by 2 into 1 plus 0.4. Then G by E equal to the 1 divided by 2.8 equal to the 0.357. Let's see the another question. The number of independent elastic constants required to define the stress-strain relationship for an isotropic elastic solid. So for an isotropic elastic solid, the material properties are the same in all directions. Due to this symmetry, only two independent elastic constants are needed to fully define the stress-strain relationship. So these constants can be any two of the following, such as Young's modulus, shear modulus, bulk modulus or Poisson ratio. Once any two of these are known, then other constants can be derived from the using the standard relationship. So our answer is the only two independent elastic constants for isotropic elastic solid material. Let's see the next question. The stress strain curve for mild steel is shown in the figure given below. Choose the correct option referring to the both figure and table. So here it is given the stress strain curve for mild steel material. Moreover, it is given the various points on the graph and also given the description of the various points. Then I have to match the correct point and its description. So let's see the curve. We know that first point on the stress strain curve is the proportionality limit. So here P is the first point, then P belongs to the proportionality limit, which is the 3. So next one is the, so after the proportionality limit, so next point on the stress strain curve is the elastic limit. So Q is the, so elastic limit, that is the fourth one. Next one is the, so middle goes to the yield one. So R represents the upper yield point. So here R belongs to the 1 upper yield point. Then after that one, so next point is the lower yield point. So S is the lower yield point. So S is fifth one. lower yield point. Then T represents the ultimate tensile strength. So T goes to the ultimate tensile strength. And last point is the breaking point or maybe fraction one. So U is the sixth one, failure or fraction or breaking point. So let's see the options. So P belongs to the 3 and Q belongs to fourth point. So P3 and Q4 and R1 and S5 and T2 and U6. So option C is the correct answer. Let's see the another question. A steel cube with all faces free to deform has Young's modulus is capital E and Poisson ratio is mu and coefficient of thermal expansion is alpha. The pressure, that is the hydrostatic stress, developed within the cube when it is subjected to uniform increase in temperature, that is delta T. So here you have to determine the pressure or hydrostatic stress developed within the cube when it is subjected to change in temperature. So here condition is given free to deform. So we know that when the material is free to deform, then there is no stresses it will be generated. So with all faces are free to deform, then stresses are 0. But it is given cube is constrained. So but here option is 0 because all faces are free to deform. But it is given cube is constrained. Then we know that when the deformation is the alpha TL, then thermal strain in x direction is the minus alpha into delta T, that is in epsilon x in the x direction. And we know that one strain due to the stresses is in the cube sigma x by E minus mu into sigma y by E minus mu into sigma z by E. But here condition is hydrostatic stress. So all these stresses in the all direction is equal to the same only. Then sigma x equal to sigma y equal to sigma z equal to the sigma. Then epsilon x direction is the sigma by E minus mu into sigma by E minus mu into sigma by E. That is epsilon x equal to the sigma by E into the 1 minus 2 mu. Then so this strain due to the hydrostatic stress equal to the thermal strain, then minus alpha into delta T equal to the sigma by E into 1 minus 2 mu. So from here sigma equal to the minus into alpha delta T into E divided by 1 minus 2 mu. But here option A is the correct. So next we have to see the next question. A rod of length capital L having uniform cross-sectional area capital A is subjected to a tensile force capital P as shown in the figure. If the Young's modulus of the material varies linearly from E1 to E2 along the length of the rod, then the normal stress developed at the section SS. So we know that one in the previous lecture already we discussed. So stress is the independent property. It is not depend upon the material properties. So it is depend upon the how much load we are applying and what is its cross-sectional area. So it is not depend upon the Young's modulus. So here applied load is the P and cross-sectional area at the SS section is the A. Then stress is the normal stress is the load applied divided by cross-sectional area, that is the P by A. So option A is correct one. So next we have to see the another question. A steel rod of length capital L and diameter capital D fixed at both ends is uniformly heated to a temperature rise of delta T. The Young's modulus is capital E and the coefficient of thermal expansion is alpha. Then thermal stress in the rod is. So here rod is fixed at the both of the end and it is given the E, alpha and delta T. So it is the direct formula only. So we know that. So thermal stress sigma T equal to the E alpha delta T. So option C is the correct. So let's see the another question. In terms of Poisson ratio mu, the ratio of Young's modulus to shear modulus of elastic material. So here it is asking the ratio of E to G. So we know the relationship between the E and G, E equal to the 2G into 1 plus 1 by M. And E by G equal to the 2 into 1 plus 1 by M. So 1 by M or mu, both are the same only. So we are using the 1 by M or mu for the Poisson ratio. So then E by G equal to the 2 into 1 plus mu. So option A is the correct. Let's see the another question. A uniform slender cylindrical rod is made of a homogeneous and isotropic material. The rod rests on a frictionless surface. The rod is heated uniformly. If the radial and longitudinal thermal stresses are represented by sigma r and sigma z respectively, then option A, sigma r equal to 0 and sigma z equal to 0. Option B, sigma r is not equal to 0, sigma z equal to 0. Option C, sigma r equal to 0 and sigma z is not equal to 0. Option D, sigma r is not equal to 0 and sigma z is also not equal to the 0. So here it is given that one rod is freely deforming. So here it is given that one rod is rest on a frictionless surface. So it is deforming the freely. So then we know that when the material is heated and due to the change in temperature it is a freely deformed, then zero thermal stresses it will be generated. So option A is the correct answer. Let's see the another question. Two identical circular rods of same diameter and same length are subjected to same magnitude of axial tensile force. One of the rod is made out of mild steel having the modulus of elasticity is 206 GPa. The other rod is made out of cast iron having the modulus of elasticity is 100 GPa. Assume both the materials to be homogeneous and isotropic and the axial force causes the same amount of uniform stress in both the rods. The stresses developed are within the proportionality limit of respective materials. Then which of the following observation is correct? Option A, both rods elongated by the same amount. Option B, mild steel rod elongates more than the cast iron rod. Option C, cast iron rod elongates more than the mild steel rod. Option D, as the stresses are equal, strains are also equal in the both the rods. So here it is given the two rods, one is made by the mild steel, another one is made by the cast iron, and also it is given the modulus of elasticity of the mild steel is 206 GPa and modulus of elasticity of the cast iron is 100 GPa, and both are having the same diameter, which means same cross sectional area and same length and subjected to the same amount of the tensile forces. So then we have to determine the deformation in the both of the rods. So we know deformation delta equal to the PL by AE. Then deformation of the mild steel belongs to the PL by A E suffix ms. And deformation of the cast iron, that is the delta Ci equal to the PL divided by A E suffix Ci. Then we have to determine the ratio of delta Ms to the delta Ci, then delta Ms divided by delta Ci equal to the PL divided by A E suffix Ms divided by PL divided by A E suffix Ci. So here same amount of the load, so P is the common and same length, so L also same and same diameter, so cross sectional area also same. So here PL divided by A, PL divided by A will get cancelled. Then delta Ms divided by delta Ci equal to the ECi divided by EMS. So here it is given the, so Ci value is the 100 and Ms value, so EMS value is the 206. Then delta Ms divided by delta Ci equal to the 100 divided by 206, which is the less than 1. Then this belongs to the cast iron rod elongates more than the mild steel rod, because delta Ms, deformation of the mild steel rod, less than the deformation of the cast iron rod, which means cast iron rod elongates more than the mild steel rod. So option C is the correct. Let's see the another question. A free bar of length 1 meter is uniformly heated from 0 degrees centigrade to a temperature of T degrees centigrade. Alpha is the coefficient of linear expansion and E is the modulus of elasticity. Then stresses in the bar is option A, alpha TE, option B, alpha TE divided by 2, option C 0, option D none of the above. Here it is clearly mentioned free bar. So bar is freely to deforming. So material is not restricted to the deformation. Then obviously stresses is the 0. So option C is the correct. So these are the 1 mark questions for a GATE previous questions. So in the next lecture we will be discuss the 2 marks questions in the stress strain topic. Thank you.